Welcome to the AP Precalculus course by Mathic Quest. Today we will be solving questions based on 1.1 change in tandem. You can download this quick revision sheet from the description below. In the first question, we need to find the following based on the given graph. The first is domain. It's simply all the x values that the graph covers. So if you look here, the graph starts from -10, it continues without any breaks and ends at +10. So the domain is all these x values, including the endpoints. That's why we will write our answer in square brackets from -10 to 10. Next is range. Range is all the y values that the graph covers. Here, the minimum value that our graph achieves is -2, and the maximum value reached is 9. That means the range is all these y values, including the endpoints. So that's square brackets from -2 to 9. Zeros are the x-intercepts. That means all these points where the graph is either touching or crossing the x-axis are the zeros. So that's x equals -10, x equals -2, x equals 6, and x equals 10. Next is y-intercept, which is nothing but the point where the graph intersects the y-axis. If you look here, at exactly 2, the graph is crossing the y-axis. So we can say that the y-intercept is y equals 2. Alright, next we need to identify where the function is positive. Now, for a function to be positive, it needs to lie above the x-axis. So that's this region, from -10 to -2, and from -2 to 6. When you write the final answer, make sure that you use open brackets, because here we don't want to include the endpoints. The reason is, at these points, the function is neither positive nor negative. That's why we call them the zeros of the function. So the final answer is from -10 to -2, union -2 to 6. For a function to be negative, the graph should lie below the x-axis. So that's right here, from 6 to 10. Alright, next we need to identify where the function is increasing. We say that a function is increasing if y increases as x increases. But in simple terms, just remember, while going from left to right, your graph should go up. So that's here, here, and here. So we can write the final answer as -10 to -7, union -2 to 2.5, union 8 to 10. Similarly, we say a function is decreasing if y decreases as x increases. That means while going from left to right, the graph should go downwards. So that's here and here, which is -7 to -2, union 2.5 to 8. Question 2. Identify where the graph is concave up. So we are looking for the intervals where the graph is bent upwards. It kind of looks like a smile. So if we look at the graph, we have an upward bend here and here. So that's from -3.5 to 1, union 5 to 10. Now, most of the standard calculus curricula define concavity over open intervals, but some textbooks use a closed bracket if the endpoint is included in the domain. In that case, this will be our final answer. A concave down graph bends downwards. It kind of looks like a frown, which we have here and here. So that's -9 to -3.5, union 1 to 5. All right, next is points of inflection. In the above two questions, we defined the intervals with upward and downward bend. Now these points here, where the concavity changes either from upward to downward or downward to upward, are called the inflection points. So this function has inflection points at x equals negative 3.5, x equals 1, and x equals 5. Question 3. Identify where the graph is negative and increasing. So we want something that's below the x-axis and going upwards. So that's here. Now this arrow indicates that it extends indefinitely. And since this is extending indefinitely, the x values are going towards negative infinity. That's why we write our answer as negative infinity to a. Next, we want the function to be positive and decreasing. That means we are looking for something that is above the x-axis and going downwards. So that's here, from point B to D. Now, we want the function to be concave up and increasing. If we look here, this entire region is concave up. But because we also want it to be increasing, we will only consider this interval. And here again, because of the arrow, we will write our interval as d to positive infinity. And then finally, we want the function to be concave down and decreasing. So concave down is here, and because we want it to be decreasing, we will only consider this interval, from b to c. Question 4. For x greater than or equal to negative 9 and less than or equal to 5, on what interval is the graph decreasing? Now first, notice that we have these dotted lines, which indicate horizontal and vertical asymptotes. So don't mistake the function here as just flat, straight lines. The function is actually getting closer and closer to the horizontal asymptote, but it hasn't arrived yet. And because of the vertical asymptote, we will write our answer in two parts. So as we start moving forward from negative 9, even though it looks like a straight line, the y values are decreasing, but very slowly. And as we approach negative 3, it decreases quickly. The same thing happens on the right. It starts by dropping quickly away from the asymptote at x equals negative 3, and as it reaches x equals 5, it starts to look flat again. But just like before, as long as it is heading towards the horizontal asymptote, it is still decreasing. So the answer is from negative 9 to negative 3, union negative 3 to 5. Question 5. Let the function f be defined as a function that is always decreasing. The table shows values for the function f at selected values of x. Which of the following represents all possible values for a? If we look at the table, here x values are increasing. And because the function is decreasing, the f of x values should decrease. Now to find the boundaries for a, we just need to look at its immediate neighbors in the table. Since the function is always decreasing, the value of a must be smaller than 8 and larger than 3. So that's option C.